guys are keen to get on. Hi, Tracy, welcome. We are busy with the data handling process, and as per the last lesson, we are in the last stage, which is the displaying data stage, where all the graphs are. We're wrapping up this data handling course. And then next week, I think, if I'm not mistaken, you guys are going to start with some revision of all the topics you covered this term. Okay, so we are busy looking at displaying data. We've covered box and whisker plots, something a little bit new. And then we're going to do pie charts, bar graphs, and histograms today. You guys all have experience with this, so we're going to fly through these questions pretty quickly. So if it feels like you're going too fast, or I'm going too fast, please raise your hand and say, sorry, Teacher Dale, slow down a bit. But we're going to try to get through as much as possible today. Okay, let's get cracking with pie charts. All right, so pie charts, the interesting thing about them is a wonderful way to display all of your data in one whole piece. And as you all know, the pie, the circular pie, represents 100% of your data. Okay, and pie charts are usually broken up into percentages and sectors, each sector representing a percentage. Okay, for example, here we have a pie chart representing people's favorite pets. We can see here that there are percentages for each sector, and this represents the whole of the data. So all these sectors must add up to the whole circle, the whole of the data set. So it must all add up to 100% of the data set. Okay, so if you have that in mind, they're going to ask you specific questions relating to percentages in a pie chart. All right, so nice and quickly, let's look at this pie chart and answer these questions real quick. You can type them into chat. Don't worry about writing them down. Which two pets did about half the learners say was their favorite? Which two pets did about half the learners say was their favorite? Anyone in chat? You can type that in quickly. Just have a look at the pie chart and then quickly type it in. I know you guys are fast on your fingers. I've seen you type WhatsApp messages to people in class. There we go. All right. Snake and fish, Tracy. Thank you very much. Good. Snake and fish. Okay. So why does Tracy say snake and fish? So the question is about half. So if we look at these sectors, it looks like these two here make up about half of the pie. So those are the two. Very good, Lorato. Well done. Okay. So snake and fish together by observation, not calculation, just by observation. We can see that snake and fish make up about half because the question said about half, all right? They're not specific about any values here. Okay. All right. What percentage of learners say a dog was their favorite pet? We can look at it straight away and see that 15% say the dog was their favorite pet. Nice and easy. All right. Question 3. Let's have a look at that one. What percentage of learners chose a snake as their favorite pet? Now we can see here that snake doesn't have a value, but if we know what we know about pie charts, we know that all these pieces must add up to 100%. So to find out what the snake is, we subtract all the others. So I'm just going to write them out here quickly. So 9% plus 11% plus 15%. And you guys can do this on the calculator while I'm writing it out, plus another 15%. And we still have 28. All right, there should be 5 sectors that we have. I'm just going to quickly check 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. All right, now we let the calculator do the work. It looks like you guys have answers already. Don't worry, Bopelo, we've just started out. We're just warming up. Okay, let me move this calculator here. All right, so 100 minus, I'm going to use brackets on my calculator. And we're going to say 9 plus 11 plus 15 plus 15 plus 28. Okay, and that should give us 22. All right, nice and easy. Okay, so the snake sector is 22% because they should all add up to 100. All right, so we understand how pie charts work. Let's give you one more to practice. Here's a question that says the pie chart below shows a survey of the different types of fruit juice bought by a group of 120 learners. We've got fruit cocktail, lychee, grape, and apple. Question 1, calculate how many learners chose each type of juice. How many learners chose each type of juice? You can put it in chat, or you can raise your hand and let me know. Should be quick calculations. I'm going to do it while you guys do it. Yeah, the grays are pretty tricky. So fruit cocktails are light gray, so I'm going to change that one. Let's change the fruit cocktail to 45. All right, so what we need to do is take these percentages in each sector and multiply by 120 learners, because there are 120 learners in this sample. So we're going to do the first one quickly. So 45 over 100. I'm going to build an equation and then just change the number in the equation as I go. So if they give you one of these questions in the exam, you build an equation and then you just change it as you go. All right, so 45 over 100 times 120, that gives me 54. I'm going to change this now to 12,5. That gives me 15. This is also 15. All right, so we've got three numbers so far. The fourth number should add up to 120. So if you wanted to check, we got 54 and 15 and 15 is 30. So 54 and 30 is 84. So 120 minus 84 should give us 36, but let's check it anyway. Let's do the sum. So just go back and change the 12,5 to 30. And there we go, 36. All right. Okay, nice and easy. All right, I think they're waiting for the hard questions, Kia.
Yeah, this is too easy for them.
It's too easy for them. All right, let me find something more difficult. Let me find something more difficult for them. This is like lower grade stuff. Let's find something more of a challenge. Okay. All right, here's a question. This is a bit subjective, no calculations. Question 2. In what way, describe it using words, in what way does the pie chart work better than a bar graph to represent this data? Another way to put this, how does a pie graph display this data differently to a bar graph? Would anyone like to turn their mics on and explain to us, how does a pie chart display this data differently to a bar graph? Anyone?
Somebody.
Somebody.
Anybody.
Anybody. Come on, Matrix. Are you tired? I think they're tired, yeah.
Yeah.
It's been a whole term.
Mm-hmm.
Come on, Ayanda. Are you sleeping? He's just watching and he looks tired. Are you tired, Ayanda? He's tired, yeah. Siani? Siani, do you want to answer this one? Yes, no, yes, no. Vopela? Oh dear, I think they're all tired. All right.
Yeah.
Tracy, do you want to give it a try? Nah, not too much. All right, everyone's just watching tonight. It's like watching Netflix.
Yeah.
All right, so pie charts, like I said before, display the data as a whole. So these are portions of the whole. All right, so these are not values, the percentages inside here. They are portions of the whole. So a bar chart, if I put some of this data back here, a bar chart will display these values that you see here. Okay, so the 15 and the 36, that'll be displayed on a bar charts bar going up. All right, pie charts don't display that value. They display what this is as a portion of the whole data set, as a portion of 120 learners. So it's very useful in showing what portion each category represents in the whole. That's when you want to choose a pie chart. Okay. No worries, Bopela, don't worry. Don't worry, Tracy. Don't stress. Okay, question 3. What information would a bar graph give you that this pie chart doesn't? Okay, so I'll answer for you. That's going to give you the number of learners, or the number, it's learners, the number of learners in each category. Okay, so this doesn't represent percentages. It represents the number of learners in each category. That's the difference between a pie chart and a bar chart. All right, let's move on. Hopefully this is more challenging. A recent survey looked at households in 2 income groups. The study determined that the percentage of monthly income was spent on food, housing, and other requirements. The part charts below represent the findings of the study. So on the left, we got spending by a household in group 1, which has an average monthly income of 3,000 Rand, and then group 2, which has an average monthly income of 20,000 Rand. So it's a good comparison. Two groups, one 3,000 Rand per month, one 20,000 Rand per month. How do they spend their money on the basic items in their home? Okay, so if we just have a quick look at the pie chart, we can see here that for the people that have 3,000 Rand a month, most of their money is going to food, which makes absolute sense because food prices at the moment are ridiculous. And then housing is about a quarter, and other spending is about 20%. Whereas the people that earn 20,000 Rand per month, yes, most of the money is going to other expenses, maybe DSTV, maybe school fees, maybe petrol, things like that. And only 14% is food. Okay, it's a very interesting comparison. Eh? Or they just like to eat. Yes, Kia, me too. It's ridiculous, ridiculous how much money we spend on food. All right, what were the average monthly incomes of the groups considered? We're not going to look at that. That's straight from the question. Question 2, what percentage of group 1's earning was spent on housing? All right, you guys are going to do this one. It should take you 2 minutes. What percentage of group 1, the first pie chart, was spent on housing? You can even look at it and get that answer. You don't need to calculate. Put it in chat. Group 1, the first pie chart, the housing. All right, that's the one that's missing. What percentage is spent on housing? Okay, you can just look at the other two numbers and work it out in your head, or you can use a calculator. A quick answer in chat. There we go. Siani, well done. 25. All right. Good stuff. Thanks, Siani. So how we can work that out is say 20 for the other plus 55 is 75. So the housing, well done, guys. The housing must be 25%. Very good. Question 3. How much was spent on housing by a household in group 2? Now this is a different. Question 1 says what percentage? Question 3 says how much? All right, now this pie chart for group 1, which is 20,000 Rand per month, doesn't show Rand values. Okay, so quick calculation here, 2 marks in the exam. Can anyone tell me how much was spent on housing? Not what percentage, how much was spent on housing? Just remember that the total that was spent is 20,000. How much goes to housing? Anyone in chat? Quick calculation in the calculator, then type it into chat.
Or you can tell us how to do it.
Or you can tell us, you can speak to us. 5,000. All right, Mango's got 5,000. Anyone else got a different answer?
Surprise us.
Or you all gonna rely on that one? All right, we've got 8,000. Anyone else? All right, let's have a look. We've got 2 answers there. Let's check them. So this is 40% of 20,000, 8,000. So this is 40% of, I'm going to write the word of 20,000 Rand. And we know the word of means times. So it's 40 over 100 times 20,000, which equals, let's do the calculator work. So let's do a fraction here. 40 over 100 times 20,000 equals 8,000 Rand. Very good. All right, nice and easy. Okay, so be careful when the question says how much. That's relating to the total pie, the total of the pie. Okay, nice and easy. Let's move on to question 4. Which group spent a larger amount of money on food? Okay, so we're not going to do this question, but I'll show you how we could. Just like we calculated how much was spent on housing, you do the same calculation for the 20,000 Rand pie. You're going to say 14% over 100 times 20,000. And then for the 3,000 Rand pie, you're going to say 55% times 3,000. Get the two values and then compare them. Okay. All right. We're working with pies, but I want to move on to bar charts very quickly. Okay. I think you guys, at any point, if you're not sure about any question specifically, raise your hand, guys, because I'm moving pretty fast tonight. I want to get to bar graphs. Let's see. Let's move on to bar graphs. Or let's try this question. Which group spent the large amount of money on food? Justify your answer by calculations. We're not going to worry about that. All right, let's go on to bar graphs. Stop me when you need to, hey? If I'm going too fast, please raise your hand. Okay, we get two types of bar graphs. We get histograms, and then we get normal bar graphs. Okay. Now, when do we use a histogram and when do we use a bar graph? So histograms is when we have grouped data. Okay, I'll talk more about group data in a moment. And we all know that histograms, the bars touch each other, as we can see here. There's no gaps between the bars at all. Okay, that's very, very, very important. All right. And histograms are usually for continuous data. Who can tell me what is an example of continuous data? Come on, Matrix, who can tell me? I know you know this. What is an example of continuous data? What is continuous data? Anybody?
Somebody.
Somebody.
Anybody.
Has no decimals. Luto, that's the other one. Hey? Continuous data does have decimals. Yeah, sorry. So your continuous data does have decimals. Your height is an example. Good, Asanda, your height, because you can measure it and you can get decimals. So think of two things. If you can measure it, like your mass, your height, a length, a time, if you can measure it and you get decimals, then it's continuous data. Okay. On the other hand, we have normal bar graphs, and these yes, Luto, can be never-ending numbers, never-ending decimals. So bar graphs is for ungrouped data. We'll talk about grouped and ungrouped just now. And the bars have gaps between them, right? That's an obvious thing. And this is for discrete data. Okay, so the two differences are continuous data, which is things you measure. If you can measure it and it has decimals, that's continuous data. Discrete data doesn't have decimals. It's whole numbers. All right, it's whole numbers. Okay, so 5 cars, 2 people, 3 days. All right, 4 houses. So when you talk about objects, and you don't want to have decimals like half a person or half a car or half a house, then they're always whole. Then it's discrete data. There's no decimals there. Okay. All right, and you can have a single bar graph. So the one that's displayed on the screen at the bottom is a single bar graph. You can have a double bar graph when you have 2 bars next to each other. For example, if you're comparing boys and girls right next to each other, you can have a double bar graph. You can have multiple bars. You can have 3, 4, 5 bars next to each other, or you can stack the bars on top of each other. So if you look at this graph that we have down here, you can show, for example, if the gray bar is for boys, you can show girls on top without gray as a white bar. You can stack them on top of each other like that. So you can show two categories at once by stacking the bars on top of each other like that. Okay, so that's called a stacked bar graph. Instead of putting them next to each other, you stack them on top of each other. Okay, let's talk about grouped data. Okay, so let's look at this histogram on the left now. All right, I'm going to zoom into it a little bit more. All right, so have a look at this histogram here. This talks about the weight of athletes. Okay, so the x-axis is weight in kilograms, and we can measure kilograms. You could even get decimals. You could get 55.23 kilograms. And then on the y-axis over here, we have number of athletes. So we're counting how many athletes. Okay, so for example, in the group which have a mass that goes from 40 to 60 kilograms. So I'm talking about a group now. There's 2 bars I'm talking about, but I'm specifying a group. All right. You can count how many belong in that group. This is why it's called grouped data. Okay. So you select a range of values. I can also choose 50. So I could say 50 to 60. Let me make my pen a bit thinner. So from 50 to 60, that group there. All right. In that group from 50 to 60, how many athletes were there? And you can read that off the bar. All right. So each group here, each bar is a group or an interval. They often call it interval data or group data. Each interval, each bar represents an interval from a number to a number. Okay. So for example, this bar that I'm coloring in right now represents all the athletes from 50 to 60. It's a group, okay, in that interval. Okay, so it's not a single category like 50 alone. It's from 50 to 60, and there can be lots of people in that group or that interval. Okay, so that's why they call it interval data. If we look at the bar graph, we can't make groups with this. Okay, we can't make groups with walk and car and bus. Each bar is its own category. All right, so we can't group things together. We can't say from car to train how many altogether in that group. They are individual categories. You can't group them. So this is ungrouped data. All right, so histograms often are grouped data and bar graphs are ungrouped data. Now, someone mentioned never-ending numbers, or the numbers continue on. Yes, okay. So you see here that this first value here is 40, and it goes up to 140. We could show 160, 200, all the way to infinity on our bar, but there wouldn't be any data for it. So we could keep showing values on the x-axis here all the way up to 1,000,000 if we wanted to, but there would be no data for it. So they've limited the x values here, the kilograms, to a certain minimum and a maximum, because this is where our data is sitting. Okay, so yes, that's another reason why they call it continuous, because it flows from 40 all the way to 140. There's no gaps between them. There's no individual categories. It's from 40 and it continues all the way through to 140. So that's also why they call it continuous data. All right. But each bar here represents a certain interval. It looks like intervals of 10 kilograms. Okay. All right. Now that we know this, we armed with this information, we can answer some questions on histograms. Okay, so here's a question. Let's read it and understand the context. It says the learners at XYZ High School wrote their first math literacy test for the term. The scores they achieved are shown in the graph below. Okay, so the x-axis is showing scores. These look like percentages. It could be out of 100, maybe they're percentages, but these are the scores, the marks. And on the y-axis over here for students, we have number of students, how many students. Okay, so for example, in fact, let's look at question 2 for this. All right, question 2 says, how many students scored between a 50 and a 60? Anyone in chat? Or we turn the microphone off and explain to us. We love hearing your voices. Shiani is fast. Shiani is fast tonight. Bopelo as well. Well done. Good. Yay, there we go. All right. So we got 5 students from 50 to 60. Okay, so in that interval of 50 to 60, there are 5 students there in this bar over here. All right. So they will call an interval from 50 or between 50 and 60. All right. Question 1. How many students are represented in this histogram? So how many in total? So have a quick look at the bar graph. You won't need a calculator for this. You add them all up. What do you get in total? Mango's got 12. All right, it's already done it. Good job. Anyone else? Confirm that number. We got an answer of 12 already. Have a look at all the bars. How many in total in this histogram? How many students in total in this histogram? Anyone else? Asanda, there we go, 12. All right, let's check. So we've got 5 in the first one. We've got, looks like 2 in the second. We've got 3 in the third. We've got 1 in the last, second to last, and 1 in the last. So 5 and 2 is 7, and 3 is 10, plus the 2 is 12. Very good. So we're counting each student in each bar. We're adding them up to make a total of 12. Very good, Lorato. Thank you. Okay. Let's move on to something a little bit more challenging. The graph below represents the salary categories of the employees versus the number of employees per category. So this is salary and how many people earn these salaries in these categories. Let's have a look at this chart a little bit more. So on the y-axis, we've got number of employees. So over here, we've got number of people, number of employees. And in the x-axis, we've got salaries. Okay, and this is in thousands. All right, so if you look at this number 310, that's 310,000. Okay, let's have a look at the questions. How many people are employed by this company? All right, have a quick look at it. I'll zoom in for you. I'll zoom in. Hopefully you can see that. How many people in total were employed by this company? Wow, Riaz, that's fast. The speed is good, Riaz. Is the quality good? Siani's got 580, Tracy's got 150. How many people in total? How many people were employed by this company? So this is a whole lot of employees in a company. So how many people are there in this company? We've got 580. Well, the people that are saying 150, I think you're only looking at the first bar, which is 150. We want to know altogether how many people in the company. We've got 580 here. Charles got 580. All right, let's check. Looks like it's 150, like you all said in the first bar, 100 in the second, 110 in the third one. We've got, looks like 40 in the fourth one. Looks like 70 here. It looks like 80 there, and it looks like it's 30 here. All right, so I'm going to get the calculator here, do the work for me. So 150 plus 100 plus 110 plus 40 plus 70 plus 80 plus 30. 580. Very good. You guys are quick with your numbers. Very, very good. Okay, well done. All right, next question. How many people are earning the lowest salary? How many people are earning the lowest salary? That should be quick. It's right there on the screen, isn't it? So this looks like the lowest bar. It has a value of 30. Yes, you should all be saying the same thing there. Well done. Good. The answer's coming in.
These people are too fast.
Tracy's like, guys, please slow down a bit. Your fingers are too fast. Okay, very good. Next question. Why do fewer people earn the highest salary? Now, that's a subjective question. All right, there's no real calculations here. Why do fewer people earn the highest salary? All right, someone turn your microphone on and talk to us about this one. You need to use sentences to answer this in the exam. Who would like to answer this? Raise your hand or turn your microphone off. You can talk to us. We haven't heard anyone. It's been chip still tonight.
Yeah, it's been crickets.
Ayanda, yes. Let's unmute you quickly.
Oh no.
Oh, hold on, Ayanda.
We have Kulekonke.
Kulekonke. All right, on the microphone's off.
There we go.
Sorry, my bad. Did I say highest? How many people are earning the lowest? No, this is how many people. The question here is, why do fewer people earn the highest salary? Why do fewer people earn the highest salary? All right, whose microphone's off? Kulekonke.
Yes, we're ready for you.
How are you?
I'm fine, thanks. And how are you?
I'm good, thank you. Is it warm there by you?
Yes.
Yeah, it's hot. It's hot here in Durban. All right. Tell us. Just turn your speakers down a little bit, and then tell us, why do you think so few people earn the highest salary?
I think. Say, can you please repeat the question?
All right, just turn your speakers down a little bit while we're doing it. There's only 30 here in the highest salary bracket from 270 to 310. Why do we have lots of people earning a low salary at the bottom, but only a few people earn a big salary here at the end? Why do you think companies do that?
Because those people have no skills.
You mean the lowest paid people? Yeah, so I agree with you there. With lowest paid people, they have less skills and they'll earn less money. Someone else raised their hand. Mango, yes?
Hi, wouldn't it be because it'd be expensive to pay high salaries to, I don't know, more people?
Good, very good. All right, if there were too many people in that bracket, the total salary bill would be huge. So they want to try and keep it to a minimum. Very good. That's a good answer. Anyone else?
Tracy in the chat says they are the bosses and managers of the company. So that could be the reason why so little people are earning so much.
Yes, the bosses and managers, which if you look at a business structure, it's almost like a pyramid. Okay, so we got this small little percentage of people at the top of the pyramid who manage everyone below them, which is a lot of people. And to be able to manage all the people below you, you have to train and get skills for that and get high qualifications. So those people who manage all the people below them will be more skilled, more qualified, and therefore get paid more. If the triangle was inverted, like Mango said, then you would have a huge portion of managers at the top and not many people below that they are managing. So the triangle would be inverted and that company wouldn't really do financially well. There was a question here from Asanda. Yes, I thought maybe I got it mixed up when I mentioned question 2. So how many people are earning the lowest salary is 115. I think maybe I said 30. So there's 150 people earning the lowest salary here. I think that's what you're trying to ask me. And 30 earning the highest salary here. Okay. Yes, JC, you are. All right. Okay, next question. Now, so that was a subjective question. Now, when they ask you questions like this in the exam, they have to award you the marks if your reason is justifiable. If it makes sense, like you guys have made sense tonight, then they have to award you the marks. Okay, so it's an opportunity to get some decent marks there for these kind of questions. All right. Oh, here we go. We're getting into the meat of it now. If the salaries increase by 6%, what will be the new maximum amount for the employees in the category 150 to 180,000? All right, I'm going to zoom out a little bit here. If the salaries increase by 6%, I'm thinking all the salaries, what will be the new maximum amount for the employees in the category 150 to 180,000? All right, I'm going to give you guys a couple of minutes to do that. So I'm going to go up to 150 to 180,000. I'm going to highlight it. It's this category here. All right, 150 to 180,000. All right, what would be the new maximum for that category if all the salaries increased by 6%? So we need, I'll write it up here, we need 6% increase on all the salaries. What will be the new maximum salary for this category over here? So what will be the new maximum salary for those between 150 and 180,000 if all the salaries increase by 6%? So what will be the new maximum? The new maximum salary for the category 150 to 180,000 if you increase them all by 6%. That's basically what the question's asking.
Now it's so silent. Everybody's working hard.
Everyone's working. Keke, how's it going there? You got an answer? Keke, what's here? You got an answer there? How's it going? I can see Konke is working very hard. Yeah, we can see. All right. Working very hard. They're good. Siani, I can see is working. Good. We got answers. Will be increased by 1,833. Okay. Asanda is saying 190,800. So Asanda is giving a new value, and Arata is telling us what the increase will be. Okay. Riaz is saying it's going to increase by 9,000. Arata, I don't think we should divide by 1,000. I think you should work out 6% of the maximum in that interval, in that bar. So the maximum value in that bar, work out 6% and increase that maximum value by 6%. Shiani's got 39,000. I think that's what that's how much increase by. Quickly Conke's got an increase of 1,900. All right, lots of different answers here. Very interesting. Lorata is appealing to her classmates. Guys, how are you getting these answers? All right, quickly says 1,800. That's how much it increased by. Okay. Very interesting. All right, let's have a look. So I'll go down to the question. It says, if the salary is increased by 6%, what will be the new maximum amount? That word is critical for the employees in the category 150,000 to 180,000. So what is the new maximum amount if you increase the salaries by 6%? So if I zoom into this bar graph, I highlight the category that we're looking at. Okay, it's in yellow there at the bottom. All right. And what is the maximum salary in that category? That's the most important thing. What is the maximum salary in that category? It's this end value, isn't it? The maximum you can get there goes from 150 up to 180,000. So that maximum salary is currently 180,000. They want to know, what will the new maximum be if we increase all the salaries by 6%? So we're focusing on that value there, the 180,000. All right. They want to know, because that's the maximum salary in that category. So you want to increase that one. That's what they want to know about, the maximum salary. All right, so we're going to take the maximum salary, which is 180,000. And we want to increase this by 6%. Now, I'm very interested to see how you guys did this. I see some of you worked out what is 6% of 180,000. But there is a real quick way. In fact, let me do the old way, the two-step way. You can work out what is 6% of 180,000 and get an answer. Let's see what that is. So 180,000 times 6%. So we're working out what is 6% of 180,000. And we see it's 10,800. Okay. Right. So then what is the new maximum salary going to be? Well, we'll have to add that on, won't we? So I'm going to add that to my 180,000. And we get 190,800. 190,800. All right, let me show you the question again so you can understand why we're doing this. They say, if the salaries increase by 6%, all the salaries, what will be the new maximum amount for the employees? Which employees? The ones in category 150,000 to 180,000. So here on the bar chart, we have a category, all right, a group, which is from 150 to 180,000. So it's this group here, that bar. What is the maximum salary in that bar, in that interval, that group? Well, it's the 180,000, isn't it? The lowest salary you can get is 150,000. The biggest salary you can get is 180,000 there. Well, what will that maximum 180,000 be if we increase it by 6%? Okay, so go to the calculation here, and I did it in 2 steps. I said, first of all, what is 6% of 180,000? That is 10,800. And then I added it on to get the new maximum salary for that category. Okay, well done. Now, can anyone? Shiani, so you're trying to work out an average between them. So if you add them up and try to work out an average and then work out 6%, if you don't work out an average, if you don't divide by 2, you won't get a nice looking value. And also that'll be an average in that category, not the maximum in that category. Okay, but your method is still the same. We just need to focus on the 180,000, Siani. All right, can anyone be brave and talk to me? Does anyone know a faster way to work out, take 180,000 and increase it by 6%? We've done 2 steps here. We've done step number 1, work out 6%. Step number 2, add on that value. Does anyone know a quick way, one line, to get this answer? Anybody? Does anyone know a quick way to work out what is 180,000 increased by 6%? Oh, you brave souls. Bontle. There we go. All right, Bontle, speak to us.
I'm not really sure, but I think we need to take 10,800, put it on top, and take 180, put it on the bottom, and multiply by hundreds. Okay,
that calculation that you're referring to is how to work out the percentage of 6%. So if you did that, that is a valid calculation to work out what percent did it increase by. So the question was, the salary went up by 10,800. What percent did it increase by? You would do exactly what you just explained to me. Okay, and you would get your answer of 6%. All right. Can anyone tell me if I want to increase this 180 by 6% and do it in one line? Can anyone tell me? Oh, this person is close. Komotso.
I think it's still Bontle on. Bontle, can we mute you?
Okay.
Thank you, Bontle. All right, someone raised their hand. Manga? You want to talk to us? Yes.
Wouldn't you say open bracket 180,000 times 6%, close bracket plus the 180,000?
You can do that. All right, let's see what that looks like. You can do that. All right, so let's remove all this. You can do all the steps in one line. So you can say, I'll just rewrite it the other way around. I'll put the 180 here first. So 180,000, add on 6% of 180,000. Very good. That is a one-line calculation that will get you your answer. Let's test it. So 180,000 plus bracket 6%. I always write my 6% percentages as a fraction like that, times 180,000. Okay, and you get the same answer. Very good. Very, very good. Well done. Thank you, Mango. Is there anyone else with an even quicker way? We're learning shortcuts here. Anyone else?
I see Asanda has a hand up.
All right, Asanda, talk to us. Hold on. There we go, Asanda.
So I'm not like 100% sure, but like we were taught something in class where you literally just add 100 to your percentage, but I don't know how it works.
Okay, it's something similar to that. So I've seen people do it like this, 106 over 100. I've seen them do that. Okay, this will get you an answer. I don't know if that's what you're talking about. So let's try that.
I don't remember how, like, because I learned it in class, but I didn't understand it. So I can't.
All right, no
Yeah.
worries. I think this is what you're referring to. So I've seen people get taught it this way. So you add 6 to 100 and you
Mm,
put it on top of the fraction. There we go.
okay.
That's what you're talking about. Very good. Yes, that's another way. So if you add
Yep.
6 for 6%, thank you. Thanks, Asana. If you add 6 to 100, you get 106. If you put that over 100, you get 190,000. Okay, very good. That'll work. I've got another way for you. If you say 1,06, now you might think, what on earth? But Teacher Dale, I know my two-step method. Why are you coming with this now? This is confusing. I don't understand. It's fine. You don't have to use this. I'm just showing you different options. You pick the one that works for you. If you are comfortable with doing work out 6%, find the value, and then adding it on in the second step, that's fine. Use what works for you. Okay, this is a method that I teach. It's very quick. If you have 6%, okay, that can be written as 1,06. You multiply by 1,06. For example, if we had 12%, you could write it as 1,12. Multiply by 1,12. If you had 0.5%, you got to be careful. So it's 1,005. Okay, so percentages can be written like this and multiplied by that value, and you get the answer straight away. It's just another option. You don't have to use it. Okay, you use what works for you. All right, whichever method works for you. Okay, I'm gonna leave that on the screen. If you want to take a screenshot of that, you can. And our answer here was I think it was 190,800. All right, that's another way to do it. Screenshot moment. All right, take a screenshot of that if you want, and practice changing the percentage. And do a two-step process, and then do the shortcut and see if you get the same answer. Okay. How, Lorato? Let's check. 190,800. Let me go back and change this to 1 comma. So 1,06. 190,800. 190,800. Oh, I think it's right. I think that's okay. Just check there quickly. All right, so we're increasing 180,000 by 6%, and we get a new maximum value of 190,800. All right, take a screenshot of that and check for me. We're going to move on to one more question. We've got time for one more. Let's have a look. All right, let's have a look at a bar graph question. Can anyone type in here what type of bar graph this is? We learned about different types. Can anyone put in chat and tell me what bar graph that is? No worries, Lorato. I also make mistakes. Okay. Anybody in chat? What bar graph is this? Stacked. Very good, Shiani. Quick on the fingers. Stacked bar graph. Very good. Okay, stacked bar graph. We're showing exports and imports in one bar. So exports are the white and imports in the gray dotted in one bar. Okay. Anyone tell me what kind of bar graph this is? It's a bar graph, but what type of bar graph? That sometimes comes up in the exam. Double, double, double. Good. Well done, Ben. Double bar graph. Very good. Okay. Here is a question. We got time for one more question. Let's pick a hard one. The graph below outlines the sales at a coffee shop made over 5 weeks. We've got week 1, week 2, week 3, week 4, week 5, and cups of coffee on the x-axis over here. Now, it's not very clear. I think this is 300, 400, 500, 600, 700, and then 800 at the top. So this is 100, and then we got 0 at the bottom. All right, here's the question. Last question. Let's pick the hard one. Question 2. What is the ratio of sold coffee cups in week 3 to that of week 5? What is the ratio of sold coffee cups in week 3 to that of week 5? So it's week 3 to week 5. What is the ratio of coffee cups in week 3 to week 5? What is the ratio of coffee cups in week 3 to week 5. Sure. Asanda's fast on the fingers. 8:7. Okay, the speed was good. I hope the quality's good. 8:600. All right. Now, Lorato, Asanda, sorry. I think your 7 needs to change, but you are close to the answer. Yeah, that's okay. There we go, Mango. That's the one I'm looking for. In fact, we can go further. We're going to get further and further as we go. Right, Mango's got 8:6. Kukle Konke, 8:6. Ben, there we go. We're getting there. Ben's got 4:2. Ben, just be careful. Simplify. There we go, Mango. 4:3. All right, Ben, you were almost there. 4:3. All right, just remember when you write ratios, you have to make them as simple as possible. Well done, Mango and Charles. All right, let's have a look at it quickly. So we've got 800 for week 3, and we've got, it looks like 600 for week 5. I want to simplify this as much as possible. Did you know that you can cancel zeros on each side? That'll get you to 8:6. All right, so as long as you cancel 1 0 on the left for 1 0 on the right, get you 8:6. What can we divide these both by? The highest factor that we can divide these both by, we can divide these both by 2. Divide them both by 2, and we get 4:3. All right, we don't want to divide this anymore, otherwise we're going to get decimal. So that is in its simplest form. Good job, well done. Okay, so remember ratios, always in its simplest form. Okay, ladies and gentlemen, we're going to stop there. We looked at a lot of graphs tonight. Okay, just a reminder, we looked at pie charts. And pie charts are a way to express the whole data set and portions of the whole data set. Okay. And we looked at bar graphs, histograms versus bar graphs. And bar graphs show continuous data and the graphs are touching. Sorry, histograms show continuous data and the graphs are touching. And bar graphs show discrete data and the bars have spaces. We learned about different types of bar graphs: single, double, multiple, or stacked. Okay, we learned about groups. So in histograms, you have intervals at the bottom and a number of people in each interval. We learned about groups and interval data tonight. Are there any questions? Anything you want me to go back to quickly before we say goodnight?
Speak now, don't ever hold your peace.
Yeah, last time I said speak now and forever hold your peace, and Kia had to correct me. So don't say that.
If there aren't any questions, I'm just going to post the link to the quiz in the chat. I'm going to quickly block the chat for now. Okay, I see Tracy has a question, said the ratios confused me. So let's quickly deal with that before I post the link.
All right, no problem. All right, Tracy, let's have a look again. Okay, so ratios. All right, so ratios are always written with a colon between them. Okay, and in this case, we need 2 numbers. They said week 3. So if we go to our graph for week 3, we got 800 in week 3. And they said week 3 to week 5. So week 3 must come first. And the number that goes after the 2 in the sentence comes second. So they said week 5 to week 5. So week 5 is the second number. And if I go across, that is on 600. So this is week 3 to week 5. Okay, now we can't leave it like that. We have to always write ratios in its simplest form. All right, so the first thing I did was you can divide by 100. All right, let's do it that way. You can divide these both by 100. You divide by the same thing on either side. The biggest number you can. So I did 100 first, and that got us to 8:6. Then I said, what's the biggest number I can divide both of these by? I can't divide them both by 4, because 6 can't be divided by 4. So let's divide them by 2. So divide them both by 2, and I got 4:3. Now, I can't go further than if I divide these by 2, I'm going to get 1,5 on the right hand side. We don't want to have decimals, so we want to leave them as whole numbers. So that is the ratio in its simplest form. I hope that answers your question.